Ladies and gentlemen, thank you for standing by. Welcome to the Future of Free Cooling webinar. During the presentation, all participants will be in a listen-only mode. You may enter questions throughout the session using the chat feature located in the lower left corner of your screen. If you need assistance or are having trouble in listening through speakers on your computer, please let us know through the chat feature so we can help. As a reminder, this conference is being recorded October 6, 2015. I would now like to turn the conference over to Ms. Lizzie Satchel, Marketing Manager at CommScope. Please go ahead.
Thank you. Welcome everyone and thank you for joining us. I'm Lizzie, Marketing Manager for Alifab's CommScope, and I'd like to take you through our agenda for today. We're going to share with you our cooling journey, how we see the cooling market today and some of the challenges you face. We'll take you through how we came to develop the Monitor product and how it can help you. And lastly, a look at how we are developing Monitor for the future. A little over a year ago, we were acquired by CommScope, and being part of this larger group has helped us expand outside the UK market. Our Monitor product has been the key driver that has taken us overseas, and we've had successful trials in Malaysia, Portugal, France, and other parts of Europe. I'd like to hand over now to my colleague Matt Berry, our presenter for today's webinar.
Thanks, Lizzie. Hi, everyone. Some of you may already know me from various different projects. I'm just going to quickly introduce myself. I'm an engineer specialized in thermal engineering and energy efficiency, and I'm in charge of developing business across Europe and further afield for Alifabs and CommScope on this range of products. Some of you may already use the Monitor product. Some of you probably do not use it yet and would like to encourage you to obviously use it. So the objective of this presentation will be to show you our thought process in how we design our product, our Monitor product, and then answer some of your questions, whether they're very technical or not. So I'm just going to start with a poll, if that's okay. And feel free to answer. There is no trap. There's no right or wrong answer. So if you just follow your screen, and you can click on whichever you think is the most relevant for you. Right, I'm going to skip to results because most of us have answered it. Obviously, the high energy usage is on the top of the list, and that's one of the key issues that the Monitor free cooling system is tackling. And we also have 18% of it's working perfectly. So hopefully these people will be encouraged potentially to switch to perhaps an even more perfect system. I'm going to ask you another question, and then it will be it for the next few minutes with questions. Thanks very much. Right, another very interesting results that shows us again that the high efficiency is on the top of the priority list. Okay, so I'm going to talk you through our thought process in how and why we have done our monitor free cooling system. So the first thing, and as we've just highlighted it on those two polls, is that the telecom and the ICT markets uses quite a lot of energy. Today, the ICT market is using more than the airline industry. That's quite a lot. I think it's about 4 to 5%. So can you imagine there are more mobile phones today on the planet than toothbrushes? I don't know if it's a good example, but it shows how important mobile is today mobile networks are today in people's lives, and how big the network and the infrastructure are on the planet. It's also at the top of the corporate social responsibility priorities, and in the ICT markets, we know how important this is. The cost of energy, well, today it's been doing not too bad actually at the pump because of some different situations in the Middle East. But there's one key trend, and we know what it is. It's not going to go down over time. So with all of these in mind, and the increase in the kilowatt-hour tariff, we're developing the highest efficiency products. So what does that mean for the telecom operators? Well, in terms of energy consumed per function, it's slightly generous from the cooling perspective because we've seen many sites are up to 35% of the proportion. But typically on average, 25% of your network will be for cooling equipment, whether it's with free cooling or extractions or with computer room air conditioning, bigger chillers for your data centers, for example. Typically around about 25% of your network will be for cooling. Our objective is to drastically cut that quarter of your energy consumption. The great majority, hopefully. In some cases, typically it will vary between 60% and 80%. This varies because of mainly three factors. The first factor is the climate, obviously, whether or not you can use free cooling, the temperature set points at which you are happy to run your site, and the heat load from the site. So there are the three key factors. But potentially, as you can see, in absolute value, so up to 2,100 euros per year per site. And that's for a net kilowatt site. So these are sites that we frequently see on the network. So really, that's the energy side of things. In terms of network infrastructure, where are the network operators today? And as infrastructure provider, but also as Comscope as a whole, we understand that there's a key shift. And these shifts, you know, some very trendy words at the minute, like cloud, RAN, and things that are basically driving the backhaul and the core. They've always been very strategic, but today the core and the backhaul are becoming denser and bigger. And some of the front haul even sometimes transforms itself as backhaul sites. The RRH technology today is driving the front haul sites to be less loaded in terms of thermal load. So it's really with this in mind, the fact that, okay, the front haul, the greatest numbers of sites on your network may very often see the heat load decreasing, despite sometimes sharing loads with other operators. So as you all certainly know, on some sites that are being shared, the load tend to increase even on front haul sites. But we see a massive increase on very critical sites. And that's the reason why we put a great emphasis on reducing the risk when you adopt the monitor system. So that shift in technology is driving cooling load of the sites. Now, in the meantime, the requirements in temperature are changing quite a lot. I've taken a couple of examples of requirements makers, the guys from ASHRAE and from Etsy that I'm sure you all know. ASHRAE dictates the requirements for the data center sites, whereas HC is more for the smaller sites. But just to highlight the fact that the thresholds in temperature have widened over the past few years. They have relaxed quite a lot. And if I take as an example, the ASHRAE in 2009 could accept to run on free cooling for more than 8,000 hours a year in about the northern area of Europe. Well, 2 years later, the latest ASHRAE requirements meant that quite a lot of new sites could be running on free cooling. And again, this is for strategic sites, data centers. In the meantime, the HC standards are actually dictating that you can run your sites above 35 degrees as long as it's less than 10% of the year. So you probably heard that there's about 8,760 hours every year. So that means that for 876 hours every year, you can run your sites above 35 degrees. So really, with this in mind, it's for us to understand and help you understand what risk you are taking in running your site warm and quantifying those risks for how many hours every year. We've seen it's been quite a hot summer, but ideally, if we can engage you in relying less on your compressors, on your high energy running compressors in air conditioning, then we will certainly reach some massive savings. So I'm going to invite you to another poll, which is more about temperature. So it's getting into a bit more technical. So I'd greatly appreciate if you could please answer this. So we've had almost everybody responded to this, but this is quite interesting. That shows that, well, actually, about half of you, but again, it depends on what sites you manage, and I'd be delighted to have the opportunity to speak to you that directly. But essentially, today the alarms, as you can see, are relaxing and be shifting towards the 40, 45 degrees, 50 degrees, and this allows indeed more free cooling. So I'm going to ask you another poll, and that's in direct relation with this question, with the alarm. So again, very interesting. We can see that there are very widespread air conditioning set points requirements. That certainly depends on the criticality of the site, but the more we can delay that air conditioning set point, air conditioning comes on. This is when the energy hungry compressor comes on. So I'll take you through our thought process to ensure that we can delay as much as possible that set point, and how we can actually do to get you to delay that set point. So we have to think really strategically, and our initial thought was to do more with less, keep the things as simple as possible, with the main objective being to increase the uptime and reduce risk. If I compare a free cooling system with an air conditioning system in the middle of the summer and you hit a high temperature alarm, well, the one which will need site intervention would be the air conditioning, because the free cooling system is very likely to clear its own alarm, especially over the night time. So that's how we increase uptime and reduce risk. We also future-proof your sites. Well, how we future-proof your sites, I will explain that later, where it's with higher air, more cooling capacity. And also defers CapEx, because you don't have to buy all these compressors from these air conditioning systems. And finally, reduce energy and maintenance OPEX. That's something that we all know. It does reduce energy and maintenance OPEX. So how we designed our products is slightly different from how other manufacturers have done it. And really, it's only a fan in the box, so it's not massively rocket science, and we all know it. But there are some things that we must take into account. And the first ones are, today's fan technology is fantastic. So electronic commutation allow fans to run from 0% to 100%. Many of them are operating on 48 volt DC up to a certain capacity. And we can add adaptive controls with different flexible controls and monitoring. The second key for us was to be able to have a more compact system where we could fit more fans and enable more airflow. And finally, a unique differentiator for our system was to use state-of-the-art filtration, something that not only can sustain for a long time, but also provides great performances and better criticality, better protection for your critical sites. I will take you through our filtration, but just going back to the basics now, I'm going to take you through all the key elements of what's in that box. The first thing is the fan. And why have we selected to use backwards curved centrifugal fans? It's pretty simple, actually. And we've got this pressure against airflow curve, which are essentially showing how much pressure and how much restriction in the air you can fight against, and how much airflow, which means how much little delta T you would, and how much cooling capacity you would be able to get out of this cooling system. And we've opted for the one in the middle, the backward curved radial fan. The reason is because it's the perfect balance between offering good resistance, good fighting against resistance and pressure, and good airflow, good cooling capacity. If you look at an actual fan, which some of you may have on their sites, we've seen that as backup fans operating on 48 volt DC. Many of them get blocked very quickly. They've got a fantastic airflow on day one, but as we add more restrictions, the airflow very quickly diminishes. The opposite goes for a forward curved centrifugal fan, where you get pretty low airflow, but you'll be able to fight against a lot more restriction. So really starting with the basics is a backwards curved centrifugal fan. And I'd like to highlight again that we have developed our own fans, and we are the only ones in the industry to have done that. And our fans are the best compromise between how much airflow you can give, the compactness in the size, and how much pressure you can combat. And this dictates how long the system can deliver the savings. So I will take you through something that may be very, very familiar for some of you, and a bit strange for some others. But essentially, the free cooling laws are pretty simple. The fan affinity law says that if we increase the fan speed, we increase the fan airflow and obviously the cooling capacity. The relation between the fan speed and the pressure is a square relation. So if we double the speed and the airflow, we double the pressure. Finally, the relation between the speed and the power use is a cubic relation. So that means that if we double the fan speed, we will multiply by 8 the power used, and this is very important. So often when we look at the specification of the fan or the specification of the free cooling system, we look at how much it can deliver, and I will definitely highlight that in this presentation. We look at how much cooling capacity effectively can deliver at max speed. But what's very important is when those fans are running at partial load, when they're running at 50%, 60%. This is when they deliver the best efficiency. They only essentially use what a light bulb would use, about 40, 60 watts. Now the heat transfer equation that's highlighted in green is also very important. And that's about it. That's all we pretty much use to size and understand a free cooling system. So the heat transfer equation just gives us the good relation between the delta T, so the difference between the external temperature and the internal temperature of your site, the airflow, and the cooling capacity. And then you can just juggle with them. As long as you know at least two, you can then understand what delta T you can achieve or you need to achieve, what cooling capacity you can achieve or you will be able to achieve, and what airflow you need to be able to deliver. Now I'm going to take you through, so these are just scientific laws that everybody uses in the industry. I'm going to take you through what makes us so different. So just thinking outside the box, you probably know many free cooling boxes. And you can see on the picture, on the scenario 1 on the left side, this is how it usually works. So it draws fresh air in, goes through the filters, and just blows in. Typically, very often, you have little grills that directs the air towards the bottom of the site, and there is a natural air displacement, sort of breaking the thermal stratification in the shelter, with the warm air being dissipated usually at the opposite side of the shelter. Well, because both solutions in both those scenarios are using centrifugal fans, it's got to be the airflow has got to be perpendicular. And in our system, to allow it to be more compact, we have designed it in such a way that basically it provides a proper downflow air displacement because it blows towards the flow, and it doesn't need any sort of direction grill to do that. So that was one of the first simple differentiators that we added to our solution. Now I'm going to start a video. Hopefully it should work on everybody's laptop. So I'm going to put myself on mute for the next 2 minutes, and I hope you enjoy the video for the next 2 minutes.
Energy costs are high. If you're running air conditioning units for equipment cabins or looking to fit newer units to comply with regulations, you may be wasting money. Every day, the cost of maintenance, electricity, and the subsequent cost to the environment in CO2 emissions will add up. There's a better solution. Alifab's monitor is an easy-to-fit, completely integrated system that drastically cuts your energy consumption. The system draws in external air through unique hydrophobic filters. High-performance, backward-curved radial fans create a positive pressure, which forces hot air out of the cabin through a damper. The result is controlled and maintained air temperature at a fraction of the cost of air conditioning. Put the numbers for conventional air conditioning next to those of Alifab's monitor, and the difference is dramatic. Our clients save up to 90% in cooling costs and CO2 emissions. And of course, the more sites you have, the more you save. Talk to us today about Alifab's monitor for new builds or retrofits.
Okay, so what makes us very different is because we think we found the right balance between efficiency and effectiveness. So just to give you a comparison, an air conditioning is pretty effective, but it's not always that efficient. Meanwhile, free cooling can be very efficient, but not always very effective. It will hit the ceiling of capacity pretty quickly. The reason why we're both efficient and effective is because we use hydrophobic filters, and I will go through it in a bit more detail in a few minutes. We propose double the fresh air airflow. So we have up to 3 fans delivering each 1,500 cubic meters per hour. We have a system that can deliver up to 5,000 cubic meters per hour on 48 volt DC. And this is not what the fans deliver in empty space. This is what the fans actually deliver in the unit. And again, this is something that's very important that often many manufacturers specify as for granted, but this is what our system actually delivers. So finally, the fact that it makes it the most effective system because of higher airflow. But by making it the most effective free cooling system, it also makes it the most efficient system, because you've seen 3 slides ago that when the fan is running at lower partial load, its efficiency is at the maximum. So it's sort of a direct consequence of the effectiveness of the system. How does it compare overall with other cooling systems? It's the total cost of ownership. The return on investments, many of you know them, they're only a few years. Typically, they're only a few years. And the total cost of ownership is also low because it's just a lot simpler to install. You don't need any qualified labor, but also it requires a lot less looking after. Our system also enables to be able to remotely control it and remotely monitor it. So it gives you an extra capacity or third-party feedback to be able to say, well, I don't need to intervene on this site. How does it compare more precisely, efficiency-wise, with split air conditioning and packaged monoblock? Well, split air conditioning, some of them do propose free cooling, some of them do have inverter control, but typically the energy efficiency ratio, the is gravitating around about 3. So that means that it's giving you 3 times in cooling what it's actually using in electricity. So for each kilowatt that it will give you in cooling, it will be burning 300 watts. Meanwhile, the packaged monoblock system will provide you with free cooling system as well. But again, the ER is only gravitating on average at around about 3.2. And this is based on the EN 14511 standard figures. Meanwhile, if you look at the monitor system with a delta T of 10 and a cooling capacity of 9 kilowatts, they deliver you an ER of 69. That's about 20 times more efficient. If we compare the free cooling, the monitor free cooling system, which is a positive pressure system, to an extraction free cooling system, as I mentioned just before, it's how well we'd fight against pressure drop. And again, our system provides quite a high column of water and quite a high capacity in terms of fighting pressure. So going through the range of all of our products, we've got right now about 5 products in our range. It's spreading from 1,500 cubic meters per hour to up to 5,000 cubic meters per hour. Specific heat transmission from 475 watts per degree up to 1.6 kilowatts per degree. And an average ER, as you can see, it's raising up with the Monitor 12 Plus system. All of these systems are running on 48 volt DC. And today they are fittable on any type of sites. Let me take you through a couple of other questions just to keep you entertained. Right. I'm quite pleased that no one answered 100%. Indeed, it's 50%. However, indeed, at 80%, it will still be using a lot. It will be a lot more efficient than at 100%. So another question. Indeed, it's double the airflow. If you put two fans in series, it will give you double the pressure available, and the efficiency is a cubic relation with putting two fans in parallel. So the lower the speed of the fan, obviously the more the efficiency you get. But there is a direct relation between the fan speed again and the efficiency of the overall system. Right. I think there's one last question for you. It's about decreasing the delta T. As you know, decreasing the delta T means delaying the time when the air conditioning system will start, or even potentially completely getting rid of the air conditioning system. Right, we've had 9 participants and very mixed return, but essentially it's increasing the airflow because there's a direct relation between the airflow and the delta T that the system will be able to achieve. Moving the heat source around will definitely favorize, will drop the restrictions on the site. And doing air displacement, as we know, will also favorize the destratification of the air and get rid of hotspots on the site. But the most important thing to decrease the delta T overall on the site is to increase the airflow. And that's what we're trying to achieve with our system. So a bit of a comparison between the filters that are being used in the free cooling industry now. And the one we use is the one that's on the column on the right. And you can see by reaching F5 N5 and the efficiency that it reaches, it can be used on very critical sites. The other beauty of the filter we use, and again, let me highlight that it's a unique filter. We are the only ones to use this type of filter in the industry. The surface area of 8 square meters, and that's one filter per fan. So that means on the monitor 9 with 2 fans, you have 2 filters. So that means you have 16 square meters of filter area. And the pressure drop on day 1, which is very low, allows our system to be running and performing the results, the energy efficiency that it provides on day 1 for a lot longer than any other systems. So what it provides you is both criticality. You can use it on critical sites. You have higher airflow, so that means you can use it on highly loaded sites. And you don't have to maintain it too much, actually. Typically, up to 24 months. But we've seen in some environments that 3 or 4 years without any maintenance whatsoever, you can run the system with no drop whatsoever in the performance of the system. So how does it compare with a typical G4? Well, we've put a curve together to just give you an idea. And when the monitor filter starts at 20 pascals and increases slowly and reaches the point when it's actually affecting the performance of the system, it takes quite a while to reach that point. Like I said, 24 months on average. Whereas typically a G4 filter will start at 50 pascals and will reach 250 pascals over a period of 12 months. That is on average for a G4 filter. So that gives you an idea of what our system can deliver. So we've gone through the fans, we've gone through the key differentiator, we've gone through the range, the capacity of the system. Let's finish with how does it work? How do we install it? And we first started in the United Kingdom by installing thousands of systems in the United Kingdom. I've taken this photo because you probably all certainly know that it does rain a lot in the UK. And it's very important to keep systems as simple as possible for people to understand how to install, for people knowing how to be trained, and more importantly, the guys who are installing the systems, after all, act as our customers. If they are happy with installing our systems, then they can promote us elsewhere. So it's with that in mind to just make sure that the guys who install it just go home as early as possible without making a bad job out of it. Essentially, that's like the system can be mounted on doors or on the sides. It's a lot more compact than any other systems. It takes between 4 and 6 hours to install, and again, no need for any particular qualified laborers, as long as they can do the electricals and potentially pierce a couple of apertures, either in the doors or in the wall. The system is up to about 30 kilos on the door, so the great majority of the hinges on sites can handle the system. So finally, how about using the system? What does it mean when it's installed on your site? Peace of mind, the most important thing. Fit and forget. When you have a system, you don't want to have to constantly looking after it. So temperature, fan PWM, the fan speed, all the alarms and the voltage can be fed back to your network operating center. And they can be fed back via different types of communication system, whether they're over IP, RS485 or dry contacts. So the system can have an IP address, and you can adapt it to your system. You can then read all of this data out of your monitoring system. Finally, I'd like to finish with something looking more into the future, because all of what I've been talking about is what we can currently deliver in pretty short lead times. But really what we're looking after today is a system that's completely autonomous. We've done quite a lot of sites where we've been refurbishing ceilings and rooftops of shelters. And by doing that, we realized, well, actually, we are using space available to have a solar array. Now, that solar array in the middle of the summer can deliver enough power to generate power for the monitor system, typically up to a kilowatt. The solar array delivers up to a couple of kilowatts, but it needs to be clean. It's been over dirty DC power. It needs to be clean, and that can be cleaned through different types of system, through modern rectifiers, as you know them, with different type of suppliers. So when you need cooling the most in the middle of the summer, you can power your monitor free cooling system directly from a solar array. Meanwhile, if you don't necessarily need free cooling, if you don't need cooling that much, you can still use it in the middle of the winter, let's say, for example, and you barely need power for the cooling system. You can use it for the RF equipment, which is more priority. So really, all of these in mind, I'd like to invite you to come back to us at any time. We'd be very happy to try to understand how we can help you. See if we can quantify the savings we can provide to you with our system, and see if our system can provide you with more resilience on your network, and more savings as well. I'm going to have to start answering the questions because we've had quite a lot of questions coming through. So I've had the question of, sorry, operator.
That's all right, Matt. We've got a few questions, so I'll read the first one out to you. Can the unit control multiple air conditioning units?
Yes. The unit can control by default up to 2 air conditioning systems. They can be either split systems or package air conditioning systems. So yes, indeed, I forgot to mention that point. Indeed, in countries or sites where it's important to still have an air conditioning system, for example, when it's above 30 or 35 degrees on the site, we can control those air conditioning systems.
Okay, thank you. How long is a delivery turnaround for Monitor 12?
Currently, from order, between 4 and 6 weeks lead time.
Okay. And do you have any delivery partners in country?
Yes, so typically we use the Partner Pro network from Comscope. So in terms of scale, it's quite large. But we're also very happy to potentially train and look after the partners of your choice in country if necessary.
Okay. And we've got another question here. What is the average payback period?
And that's a very good question. Actually, that goes back to the slide number 34. But a few years, typically a few years is our target. So between 2 and 3 years, typically. It depends, again, it depends on many things. Like I said, the heat load of the site, the set points, the climate, and the kilowatt hour tariff that you pay as well. Because on some sites, for example, in Africa, where you use diesel gensets and you pay $1 per kilowatt hour, the payback can be a lot shorter.
Okay. And what is the percentage of energy saving?
Typically on the site, it can go up to 20, well, to the majority of the 25% I was mentioning earlier. That's total of the sites. On cooling, it can go up to 90% of the cooling.
Okay. And we've got one final question here. Does the system have the ability to log data?
Yes. So the system by default offers a plug-in IP Ethernet, which you can just plug onto your IP network operating center and log all the data that it collects. So you can log to your network operating center and do the integration work to have all the data from the system. So PWM, the fan speed, the temperature, the voltage that the system is measuring, all of these data can be measured by default.
Okay.
Remotely.
And we've had one final question just come in. Do you have information how the cooling needs are developing nowadays when a lot of operators are using RRH as standard technology for radio access?
So that's probably going back to the trend slide that I was showing about half an hour ago. But yes, indeed, the remote radio head technology is driving the site load to decrease. But again, that's most of the time on the end terminal site, on the front haul site. Meanwhile, the backhaul sites and the core sites, which are also very critical, are seeing the heat loads rising. And also, we've got to bear in mind that despite the RRH going up the mast and the heat load also going up the mast, there are still BBUs to protect, to thermally protect. There are still energy equipment, batteries to protect, and potentially there are co-locations on sites. So co-hosting can drive sites loads and heat load to increase as well.
Okay. And sorry, we've got one final question. What is the filter life?
The filter life, as I was saying, it can be up to a few years. This completely depends on where the system is installed. So like I was saying, the pressure drop of the filter is the lowest in the industry, and the surface area of the filter is the highest in the industry. So with these two factors in mind, the filter life is a lot longer, typically double than any other filters. So typically a few years. So in some places we can see 3 to 4 years without any maintenance, but typically a good couple of years is a good average benchmark, 24 months.
Okay, thank you. Well, that wraps up our questions, Matt. So thank you everyone for your attendance. Following this webinar, you should see a small survey on your screen, and we'd be very grateful for your feedback. If you have any further questions, please do get in touch.
Thank you.
Thank you.